Another case study on internal rate of return. We have to calculate internal rate of return where we are given information about cash flows. Year 0, this is an outflow. Year 1 to 5, they are all inflows. So very simple, you are given the outflows and inflows for a period of 5 years. You have to find out IRR. So the first question which you have to ask is, what is the nature of cash flow? Look at the cash flow. Each and every year it is different. Actually, it is declining each and every year. Okay. So this is differential cash flow. In case of differential cash flow, how will you find out IRR? Using trial and error method. Now, in trial and error method, you have to make arbitrary assumption of rates. Now for that we have a guidance, that is we will find out what is known as investment factor. What is investment factor? In investment factor we will take the total outflows towards the project, we will divide it by average cash flow. How do we find out the average cash flow? Take all the 5 years, sum them, divided by 5 years. That would give you the average cash flow. If that average cash flow is divided from your outflow, which is 384,000, you will get investment factor. That you have to trace in which table? Present value annuity factor table, and that will give you, and in across how many years you have to trace? You have to trace across 5 years. So that will give you the range of IRR, that is the percentage at which your IRR is lying. But one thing you have to keep in mind, this investment factor will not give you the exact IRR. Okay, this investment factor will not give you the exact IRR. Here, please look at the cash flows. 150, 125, 100, 75, 50. It is going down year after year. So even if you compute the average cash flow, please be very clear that that average cash flow will not represent these cash flows, because the cash flows are going down year after year. Okay, so you have to keep that in mind, and only then you should proceed. Okay, so what is going to be our first step? Our step 1 will be finding out what is the average annual cash inflow to have in your investment factor computation. And how do we find out average cash inflow? You have to total all the 5 years cash flow divided by 5. Okay, so let's do that. Let's total all the 5 years cash flow, and we have to divide it by 5 years. So that gives average cash inflow, which is 100,000. Then step 2, we can find out the investment factor, which is nothing but investment made divided by average cash inflow. So investment made how much? 384,000. Average cash inflow is 100,000. So we get 3.84. So that's your investment factor. Then comes step 3. What you have to do is, you have to trace this 3.84 in present value annuity factor table, and if you do so, you would notice that 3.84 is lying between 9% and 10%. That's what I have captured here as step 3. That is, discount factors corresponds to 3.84. So instead of discount factor, I would say discount rate. Discount rate corresponding to 3.84 or 9% and 10%. It means this 3.84 is actually lying between 9% and 10%. But please don't jump to conclusion that your IRR is going to be between 9 and 10, because your cash flows are not annuities. You don't have average cash flows. Your cash flows have a different pattern. So it may not lie between 9 and 10%. Okay. So keeping that in mind, what we'll do, from this 9 and 10, let's select one rate and we'll try to find out NPV. So that's what we are going to have as step 4. We'll find out NPV at 9% first. Let's find out NPV at 9%. So what we have to do? We have to bring in year, then cash flows, NPV or say present value factor at 9%. Then if you multiply these cash flows with present value factor at 9%, you get PV at 9%. So let's capture everything. And I'm starting from year 0 itself, so that in the end automatically we'll have NPV. So year 0, 1, 2, 3, 4, 5. All the years are captured. Then let's capture all the cash flows. Year 0 there is an outflow, then from year 1 to 5 there is an inflow. So all the cash flows are captured. Now PVF at 9%, it is nothing but the formula 1 divided by 1 plus I to the power n. So if we apply that formula, for year 0 it is always going to be 1, for year 1 it is 0.917, 842, 772, 708 and 650. So now we have to multiply this cash flows with present value factors, so that we get present value at 9%. So the multiplication gives these values For year 0, it is same 384,000 into 1, outflow of 384,000. Then for year 1, 150,000 multiplied by 0.917, we have 137,550. Year 2, 3, 4, 5, we have to multiply with respective values, and these are all the numbers. Okay. Now, if we total this is nothing but the PV of inflow, whereas this is outflow. So inflow minus outflow obviously would give us the NPV, and NPV here is 21,600. So what we understand is, if you are going to discount the cash flows at 9%, you are getting a positive NPV. So it's a message that this 9% is not your IRR. Okay, but how we chose 9%? We chose 9% because of investment factor. Investment factor computation said IRR is lying between 9 and 10%. Okay, so what will happen if we choose 10%? But in the beginning itself, I gave you a warning, or I hinted saying that don't believe investment factor, because investment factor is calculated based on average cash flows, whereas your cash flows are not average cash flows. So to understand what will happen if we go with investment factor, let's take 10%. And I am telling you now itself that 10% will not give you IRR, but to understand the concept that why you should not believe investment factor when you take average cash flows, let's take 10% and see. Okay, it means now we have to discount at 10%. So let me capture it here. Yeah, present value factor at 10%. For year 0 it is 1. For year 1 it's going to be 0.909, 0.826, 0.751, 0.683 and 0.621. And how it is calculated? Again, it is 1 divided by 1 plus I raised to the power n. Okay, so now what we have to do? We have to multiply this cash flows with this present value factor at 10% to know what is the present value at 10%, and these are all the results. So you get your inflows, compare it with outflow, both are in PVs. So total of all this, including the negative item, you get a number, and look at that, it is still positive. Are you getting the message? When you discounted at 9%, it was positive, but your investment factor said is your IRR is lying between 9 and 10. So when you tried discounting at 10%, it is still positive. It means your IRR is not lying between 9 and 10, it is beyond that. So that's why I said don't believe on investment factor, just take it for guidance. Your investment factor will say your IRR is lying between 9 and 10. It would work when your cash flows are annuity or when they are very close to annuity. But in this case, if you look at the cash flows, they are going down year after year. So your average cash flow will never represent each and every year cash flow. So it will not be accurate. Okay. So it's a lesson for us that we should not take investment factor for granted, especially when your cash flows are not very close to average. Okay. So now what I should do? This 10% is not working because I tried with 9%, I tried with 10%, but this 10% is little closer to NPV, or I would say it is little closer to 0 NPV when compared with 9%. It means my IRR is going to be greater than 10%, so I have to try out with some other rate. Okay, so let me try out with some other rate, say something like 12%. Okay, so I have to find out the present value factor. It is 1 divided by 1 plus 0.12 to the power 1, 2, 3, 4, 5, and for year 0 it is 1. Let's do that. So these are all the factor values. Then what we should do? This cash flow have to be multiplied with this present value factors, and if we do that, we'll have present value at 12%, and the calculation gives these numbers. So now what is the NPV? NPV, watch out, your NPV is negative 3175. So what is the understanding? Your IRR is lying between 10 and 12. You can also say it is lying between 9 and 12, but very accurately it is lying between 10 and 12. Okay. So now I am going to apply this interpolation technique to find out IRR. So let's see. IRR is equal to base rate plus NPV at base rate. Here I have written it as lower rate divided by NPV at base rate, lower rate, minus NPV at next rate. Here I have written it as higher rate multiplied by difference between the rates. Okay. So what is the lower discount rate I am taking? I can take 9 also, but I know it is very well lying between 10 and 12. So I am taking 10 as the lower rate. So 10% plus NPV at base rate, that is lower rate, 12,975 divided by NPV at base rate 12,975 minus of minus NPV at next rate, which is 3175. So minus of minus, so it becomes plus. Multiplied by difference between the rates. Let me cut this percentages. We'll simply say it is 12 minus 10. We'll simply say it is 12 minus 10. Okay. Here also I want to cut this percentage. I don't want this now. Okay. So it is 10 plus 12 975 divided by 12 975 minus 3175 multiplied by 12 minus 10. So this calculation takes me to something like this. So eventually, now please, I am removing all these percentages. I don't want that. Eventually we'll express everything in percentage. So it is 10 plus 12975 divided by, look at here, 12975 minus of minus, so it becomes plus 375. So it is 16150 multiplied by 2. So eventually you will get a number that is 11.607. I can round it off to 11.61, and finally I'll express it as percentage, because internal rate of return have to be expressed in percentages. Now why I avoided these percentages? Basically to avoid some kind of calculation confusions. Okay, because eventually we are trying to calculate the rate of return in percentage, so let us avoid the percentages in the in between stages. Finally I said it is 11.61 percentage.